my friends. Welcome back to a tutorial about machine learning with Python, where, as you already know, we talk about different machine learning algorithms, and then we try to implement them from scratch in Python without using the SciKit-Learn libraries. But we obviously use the SciKit-Learn library to verify the results that we get. In the previous videos, we talked about the k-nearest neighbor. We talked about the linear regression and the naive Bayes, right, in these two slides. And now let's talk about the k-means. K-means is obviously another machine learning algorithm. It's unsupervised, and basically the main idea behind it is that if I choose this guy in here, let's say that I have some data. Let me plot some data in here. And you have some random data points, right? And yeah, something like this. Usually, when you look at it, you're like, okay, probably like this is one cluster of data. This is another cluster of data. And then like this is one more cluster, right? So yeah, visually, like you can categorize this into three different classes. But how can we like write a machine learning algorithm that does this for us using the k-means algorithm? Basically what it does, the k-means algorithm, is that it says, okay, how many classes do you want? And you say, okay, I want, for example, 3 classes. And it says, okay, so I randomly assign 3 points as the center of the clusters, right? You can either add new points to your data and be like, for example, I don't know, like this is one in here, this is one in here, and then like this is this one. Or you can randomly select 3 of your input points as the initial guess, right? Let's do that now. I come here and I say, okay, like I randomly selected this one, and I randomly selected this one, and then this one in here, right? And then what happens next is that you have to calculate the like all the distances for each point to each of these 3. So I'm just gonna be like, for example, this is closer to this one, 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 this is closer to this one. So I'm gonna say that like this is one category, and then like these maybe are like the second category, and like this is the third category in here, right? And then like you keep doing that iteratively. Like what happens next is that you calculate the mean, the average value within this. Like maybe like these 3 points that they selected are not really the best points. Let's say that I select like this one in here, this one in here, and this one in here. This is random, right? So anything could happen. If you're lucky, sure, yeah, maybe you can get it in the first iteration, but sometimes I think it takes a while. I know like here when you categorize it, it says, okay, like this is one category, this is like a second category, and like this is the third. Maybe, I don't know. And then what happens is that like you have to calculate the mean inside each, right? And those are going to be your new centers, right? So if I select this guy and come here and say, okay, within this category, the mean seems to be here. So this is going to be my new center. Here, this point seems to be the new center. So that goes there. And here, this seems to be, for example, the average value, right? And then you do the same thing. You measure the distance from each point to each of these 3 points, and you put them in the class which is closer. And you keep doing that until nothing changes, right? Or until you're happy with the result. But ideally, the algorithm is going to converge and it's not going to change anymore. So this is basically all you need to know about the k-means algorithm in theory. Regarding the theory and the math behind it is, as you saw, it's like super easy. Nothing too complicated about these algorithms. And let's actually see how we can do this in Python now. As always, I'm going to start with implementing the kmeans algorithm in Python using the SciKit-Learn library. So let's go import numpy as np, import SciKit-Learn. Let's actually do it this way again. From SciKit-Learn, import data sets, again from SciKit-Learn dot cluster, import kmeans, and from SciKit-Learn import, well, we had it up here, so we can actually put it here, right? Import metrics, for example. And as we said before, we're going to set the random seed numpy dot random dot seed. We're just going to set that to 0. And let's actually start. So x and y equals data sets dot make blowups. That's like basically this function creates something for you similar to the graph that I just showed you in the PowerPoint slides. So I'm just going to say, for example, centers equals, I want like 3. You can have as many as you want. Number of samples. Number of samples equals, let's say 100. And number of features, that equals to 2, for example. You can have anything. Now actually let's use the Pythons or the SciKit-Learn library for that. So I'm just gonna create an object, kmeans, that equals kmean that we imported up here. And so the input to this object or to this class are a number of clusters equals to 3. And then we can go max iteration. As I said, it's like an iterating approach. So you can specify that. I'm just going to say, like, let's go with 200. And what else do we need? Random state, that equals 0. You can read about, different options, but like I've talked about the kmeans algorithm in a separate video in advanced Python topics. And I'm not going to explain it again here, but if you're interested, you can check that video. And I'm just going to go auto in here. Once you have that, you can just go kmeans dot fit. Just notice that because it's an unsupervised learning, we don't really need to create like chain and test data because like it doesn't really mean anything. And you don't actually need this y here. Like just maybe for accuracy and comparison purposes, but like you don't really need that to train your data. So I'm just gonna fit or train my model using the X input. And as you remember, we had like accuracy equals metrics dot just the rand score, and I'm just gonna give it y and kmeans dot label underscore, and that's about it. And then I can go print f SciKit-Learn kmeans accuracy is, and then I can put ACD here. So if I run this now, let's see what we get. If I run this, it runs and it says the SciKit-Learn kmeans accuracy is like 72%. Okay, cool. We can actually like multiply that by 100 if you like that. So anyway, so that seems to be working, cool. And now let's start writing our own. So let's get started. I'm just going to define a class. I'm just going to call it my kmean. And we're going to have like an init method underscore init, right? Obviously, self goes in here. it's a k-mean algorithm, so we need k, and just like by default set it to 3. Can be anything. Max iter, I'm just gonna set that by default to 100. That should be good enough for now. If we can keep adding to this, if we needed more. So I'm just gonna go self.k that equals k self dot max iter that equals to max iter. Okay, I misspelled self here. Self. Okay, and okay. The other things that we need like a list of our centers. So I'm just gonna go self dot centroids. That's what it's called, like the official term for that, centroids. It's an empty list for now. And then I want to initialize my clusters as well. So self dot clusters that equals to a list, like an empty list for whatever in range of self.k. So what happens after running this line, it's going to create, for example, for k equals 3, it's going to create an empty list of 3 empty lists. So it's going to be a list of 3 empty lists. And inside that list, I'm going to keep adding the points where like the data from the data set that I have, and they belong to that specific data set. This should be it about the init. As I said, like if we needed something else, we can always come back and add it here. Now let's go define predict, right? It obviously has self. And x, there is no y because it's unsupervised. I'm just going to close this so we have enough room here. I'm just going to go self.x that equals x, and self.number of samples. We've done this a lot that you already know what I'm going to do. Self.number of features, that's equal to x dot shape, right? So for example, in this example, we created like 100 samples with 2 features. So when you get x dot shape, number of samples is going to be 100, number of features is going to be 2. Okay, so far so good. The next thing we need to do, the next step would be having some initial guesses, right? Where the 3, well, in this case 3, where the 3 centers are going to be, right? So I'm just gonna go init guesses that's equal to I want to randomly choose some of the input data that I have. So I'm just gonna go numpy dot random the choice. We have to give them a range, okay? Like you want to generate random numbers from like what range, 0 to what. So you have n, like you have number of samples, so you want to create like a number between 0 to that. So I'm just gonna go self the number of samples, and how many do you want? I want self.k, right? And there is this cool option called replace equals false, which basically means that if you chose like 2 same numbers, like if you chose 10, 24, and 10 out of 100 samples, because you have like 2 10s, it's not going to be like that. When you set this to false, it means that I want the values to be unique. And now that you have the basic values, like you have the random values, you want to say self.centroids that equals to self.x I for I in init guesses, right? So far it makes sense. So we generated some random numbers and we're just using those values to set our initial guesses for our centers, right? So what's the next step that we need to do? Now, I want to say, like, this is the optimization. This is the, like, iterative part that happens. Now, I'm just going to say for whatever in range of self dot max iter. I say max whatever in this range because I'm not gonna do anything with this loop index, right? It's just like something that's supposed to loop, and that's about it. So for that, let's see what we want to do now. Oops, I added like a column here for no reason. So what do we want to do, right? We want to update our clusters, right? So I'm just gonna go self.clusters that equals, we want, like, we have the centroids. We want to measure all the distances from different inputs to those 3 centroids and like make a cluster. Sounds like it's going to be a helper function. So I'm just gonna call that self dot underscore make cluster, right? And then I'm just gonna pass self.centroids in. So let's assume that we have this function. We're gonna write that later. But let's say this is a function that like get the centroids and make a cluster of the input data based on these. Now that we have a clusters, we want to compare it with the old values, right? Because you want to know if it's not changing anymore, we don't really need to do like keep doing the loop, right? Let's say like the max iteration is 1,000. If you converge and the centroids are not changing after iteration 100, then you don't really want to do anything. You just want to be like, okay, why would I want to iterate like 1,000 times if it's not going to change anything? That's what we want to do. I'm just going to go old centroids. That's equal to self.centroids, which is the new value. And I'm going to update the new values with what I have. So self.centroids. So this is like preserving the old values here. And now here it's going to be self dot. We're going to need another helper function. But for now, I'm just going to say calculate centroids, right? And the input to this function is obviously the clusters, right? Self.clusters. What am I doing here? Self.clusters, right? So this helper function would get the clusters for us and calculate the new centroids. And now we want to say if like the old centroids are the same as the new ones, then break, right? So we're going to need a function to do the calculation and like measure the distances between each point in this and with the new ones. So I'm just going to define a function, not as a helper function because it doesn't have to do anything with this class. I'm just going to go def dist to calculate the distance between point 1 and point 2. It's going to be return numpy.sqrt of numpy.sum of p1 minus p2 and that's scored, right? So this is our dist function, just like basically measures the distance between 2 points. And then here I can say, after we update the values, I can say that distances, right, that equals, I want to call the dist function that I just defined between old centroids of I, that's my first point. The second would be self.centroids I, and that's for I in range of, we have 3 clusters, right? So it's going to be self.k. And I want to go if sum of distances, if that number equals 0, it means that I'm not updating anymore. So break the loop, right? So that's about it. So we have to define these 2 functions though. So let's just go over it one more time. we create the new clusters, right? Preserve the old centroids, calculate the new centroids based on the clustering that we did here, and then we calculate to see if like the old ones and the new ones are the same or not. If they're the same, it means that the algorithm has already converged and we don't really need to continue our loop anymore. So that's that. And then now that we have the clusters, I'm like, everything is okay after this for loop. Whether like the max iteration has reached or we've broken out, we have to return the labels, right? Because like now it's like clustered and we want to see like the cluster values. So I'm just going to define labels that's like an empty list. But instead of an empty list, I'm just going to go and imply that empty, right? And I'm just going to give it self.number of samples. It's like an empty list of like, you know, this size. And because I want to, like I have a number of samples, like this many samples, and I want to have like a class or a cluster for each of them. How do I do that? I'm just going to go for I just want to iterate over each cluster, right? So I'm just going to go for I and C in enumerate of self dot clusters, right? So I would be the like loop counter, and C is going to be each cluster. So it's like in this example again, C is going to be like the first time is going to be the values in the first cluster, or all the points in the first cluster. In the second iteration is going to be all the points in the second clusters, and so on and so forth. But now within each C, I have to loop over, right? For each sample, as short for sample, in C, right? I'm gonna go labels S that equals I, right? And then I wanna, return labels. What did we do here? So we go over the first, let's say, this is just as an example so you know what's happening here. Let's say our clusters are like this. These are the value of the first cluster, like data point 4, 3, 1, and 7 fall into the first cluster. I don't know, 5 and 2, they fall in here. And then 8, 9, and 0, they fall into the third cluster. So the first time that we get here, C is going to be this list. And I is going to be 0. And I'm saying, excuse me, for S in C, so S is going to be 4, 3, 1, and 7. I'm saying label S, so label 4, which is like label for data point 4, is going to be I, which is 0. So for all these, I'm going to assign value 0 for the label. For these two, I'm going to assign value 1. And for these three, I'm going to assign value 2. Okay, so that's good. And now let's define our helper functions. Let's start with this calculate the centroid. I'm just going to go define. Let's bring this guy over. Name of the function is that. And it's going to get the number of clusters. So self, right? And it gets some clusters. Note that I'm not giving it self cluster because it doesn't really mean anything. Like it's just a helper function, right? The self makes it so that like every global variable that we have inside the class like visible to this helper function as well, or helper method if you want. So I'm just gonna go centroids, right? We want to calculate the centroids. So we have to initialize it first. np.zeros of self.k and self.number of features. So I initialize the centroids. Now I have to, actually calculate it, right? So I'm just gonna go for I and C in enumerate of clusters, right? Again, look at this example here. So first time it's going to be like these 4 points. So what do I want to do? I want to go centroids I, that's equal to, it's the mean value, right? This is what we said when we're talking about the theory in the PowerPoint slides. We have to calculate the mean of like whatever value is there. So this is like data point 4. This is data point 3. So I can just go numpy that mean, get the average of self.x of I, right? Oh, sorry, C. And then I can do that over axis equals 0. So I'm just like getting the mean value, right? So I'm saying like for this, get the mean value. For this, get the mean value. For this, get the mean values. And now that I have that, I can simply just go return centroids. Okay, so that's the first helper function, which is clear. And now let's define this guy. We can come here and say define, make clusters. Obviously, it's going to get self and some centroids, right? So what does this function do again? It gets the centroids and measure the distances. And based on the distances, it creates the cluster. So let's just close this so we have more room here. And how it works is that I'm just going to define clusters as an empty list for whatever in range of self.k, right? Just like how we did in the init method. And here I'm just going to go for I and S in the memory rate of self.x. So for all the data points, I don't know what happened here. So for all the data points, what do we want to do? We want to calculate them, the distance. We want to find the closest one. Let's actually do it like this way. I'm just going to go centroid I, that's equal self dot. I'm just going to have like another helper function, and I'm just going to call that nearest centroid of S and centroids. So what's going to happen is that I'm going to define this helper function that gets the sample and gets the centroids and returns the closest one, basically. But let's say that we have that function. We're going to write that function in a second. Now that we have the centroid all we need to do is to go clusters of this guy, right? We need to put the corresponding data points here. So this equals, or we can actually go depend I, right? And then like once that's done, we can just go return clusters. And now let's define this last helper function, hopefully. So I'm just going to go define that, and it's going to get self, point, and centroids. And all this function does is that it goes distances equals just like what we did before. So dist of point and x for x in centroids. So we have 3 centroids, right? It gets each point, measure the distance from that point to each of those centroids, and it creates a list, which we call the distances. Now we want to go nearest index, right? That's equal, we have to basically find the smallest value in distances. So we can go numpy that argmin of distances, and then we just return that, right? Return this guy. So let's see what happened again. So we have this helper function. It gets the point and measures its distance to each of the centroids and return the smallest one. And we were using this helper function in the make cluster function, where it gets the centroid and it comes here for each of the points in our data set. It does the same thing, update the centroids, and makes the cluster for us. So that should be it. I guess we have everything that we need. Now let's actually use what we have. I'm just gonna close this, close this, close this. I'm just gonna go km equals my kmean, right? And what is k? Like by default, we set it to 3 here, but we can do something cool. We can like say, we've seen it in this, like in a previous example before. I'm just gonna go length of numpy dot unique of y. So y was the number of up here. We define y as like the labels that we have, and numpy.unique just like returns the number of classes in the data set that it generates for us. We know it's already 3. You can print that to make sure, but it is cheap. So that's that. And max either by default we set it to 100, but if we want to compare that against the exact model from SciKit-Learn, we set it to 200 here. So I'm just gonna go 200. And then you can go ypred. The predicted values are obviously km dot predict x, right? You give it the input data and it just returns the values. And then you can go accuracy equals metrics, or how did we call this guy up here? Metrics that. Let's just copy this. I'm just gonna go down here and say accuracy equals metrics adjust grand score y, and instead of what we have before, I'm just gonna use ypred, and this is the our alone kmeans accuracy is this. Hopefully they match. Let's see if we run this. We're going to get the exact same value, 72.01372. So yeah, they match. Awesome. So that's about the kmeans algorithm. Hopefully we covered everything that you were hoping for when you clicked on this video. And please don't forget to subscribe to my channel so that you won't miss the next videos. And also you help me and support me. See you guys all in the next video. Have a good one. Take care and bye-bye.